Refraction through lenses. Basically, there are two types of lenses: convex lenses and concave lenses. Again, there are three types of each type: three types of convex lenses and three types of concave lenses. Convex convex, plane convex, concave convex, concave concave, plane concave, convex concave. Now let's see refraction through a convex lens. A light ray incident parallel to the main axis converge to a point on the main axis of the other side of the lens, and that point is called the primary focus of the lens. A plane parallel to the vertex of the lens through primary focus is called the primary focal plane of the lens. The length between the optical center of the lens and the primary focus of the lens is called the focal length, and it is denoted by symbol F. A point on the main axis at the other side of the lens from the same distance as the focal length on the main axis is called secondary focus. A light ray incident through the secondary focus continue parallel to the main axis after refraction through the lens. A light ray incident through the optical center continue with no refraction. A parallel beam of light incident not parallel to the main axis will converge to a point on the primary focal plane. Now let's see refraction through a concave lens. A light ray incident parallel to the main axis diverge from a point on the main axis, and that point is called the primary focus of the lens. The length between the optical center and the primary focus is the focal length of the lens and is denoted by symbol F. A point on the main axis, other side of the lens at the same distance as the focal length is called the secondary focus. A light ray incident towards the secondary focus continue parallel to the main axis after refraction. A light ray incident through the optical center continue with no refraction. A plane parallel to the vertex of the lens through primary focus is called the primary focal plane. A parallel beam of light incident not parallel to the main axis will diverge from a point on the primary focal plane. Images formed by a convex lens. When the object is between optical center of the lens and secondary focus, that is, object distance u is less than focal length f. A vertical, non-inverted, enlarged image is formed at the same side. When the object is on the secondary focus or object distance u equals focal length f. Refracted rays are parallel to each other, therefore the image is formed at infinity. When the object distance is greater than f but less than 2f, the image is formed at a distance greater than 2f. The image formed is real inverted at a distance greater than 2f. When the object distance is 2f, a real inverted image formed where image distance also equal to object distance of 2f. When the object distance is greater than 2f, a real inverted image is formed where image distance is greater than f but less than 2f. When the object is at infinity, a real image is formed at primary focus. Now let's see graphically representation of image distance versus object distance. This is the variation of image distance against object distance in case of a convex lens, the graphical representation. Images formed by a concave lens. A virtual, non-inverted, smaller image is formed between optical center of the lens and primary focus wherever the object is.